All right, guys, welcome back. Last week we were covering balanced and unbalanced forces. We took our quiz. Most of y'all did very well. Congratulations. Kind of tying what we were doing before. Unbalanced forces are what resulted in movement. Remember, balanced forces, we stated that an object in motion stays in motion. An object at rest stays at rest. So we're looking at unbalanced forces with this. This is talking about things that move. All right, so we're looking at speed. We know speed is how fast something goes. And you see this triangle here. The D stands for distance, the S is our speed, and our T is our time. We're going to talk today about how they tie in together. Now, if you see my copy, I have on the top corner, start point A, and it follows along the distance in orange to time, which is in red, to point B, our finish. Speed, we're going to represent with blue. So at this time, grab your orange, red, and blue color pencils so that you can mark the speed, distance, and time on your sheet. Go ahead and pause the video now so you can take a few moments to do so. All right, let's look at our triangle. I'm going to give you a couple moments again to color in the triangle. We have the triangle done in yellow. We have the D colored in orange for distance, the letter T done in red for time, and again the letter S for speed done in blue. On the left-hand side of your pyramid, you have a number 1. You've got 3 formulas that we're going to be using for speed, distance, and time. The first one is time equals distance divided by speed. I noted in my notes time in red, distance in orange, speed in blue. You can mark them in the same color with your pencil. I did it so you could kind of see it a little better. So if the problem is asking us to solve for time, this will be the formula that we use. Now on the right side, you have a number 2. For that one, we're looking at speed equals distance divided by time. If you notice, we're using the same numbers or the same information, just in different places. Speed equals distance divided by time. Time equals distance divided by speed. On the very bottom of our triangle, we have distance equals speed multiplied or times time. So you've got distance equals speed multiplied by times. If you have a question that asks about the distance, solve the distance. How far did they move? That's what the formula that we're going to use. Some other words we're going to look at. Instantaneous speed. That's the one I have written in green. This is the rate of motion at any given instant. An example would be a speedometer. A speedometer, think about when you're in the car and they're asking how fast are you going. Or if you play baseball, they go ahead and record the speed of the ball as it hits or crosses the plate for the pitcher. The example we have written here, a runner's speed changes from instant to instant. Right underneath, you have the average speed. That is the total distance traveled divided by time. If you notice again, I went ahead and color-coded those words. I would either capitalize them, or if you have your colored pencils, maybe color around them so that we can go ahead and make sure that they stand out. Right underneath average speed, you've got two bar graphs, or two line graphs, I should say. If you notice again, distance and time, distance and time. Time is showing on the x-axis, distance is showing along the y. Now, what we need to remember is the steeper the line or the slope, the higher the speed. Meaning the faster the object is going, this line is going to be a lot closer to the y-axis or to your distance. The slower it's going, it's going to be closer to the x-axis. Now, if the line is going consistently straight, remember it remains constant. Constant, we said, means the same, no change. Then it's going to be a flat, straight line. Think about a heartbeat. If it's flat lines, then it's not pumping blood anymore. And that's not good. Now, before we move on to the examples, I want to show you in these three boxes where it says units of measurement, we're actually going to put the steps to solve the problems instead. So step 1 in the first box, please write down step 1, formula. For that, we determine which formula are we going to need. After you read the problem, think about what is the question asking me. For step 2, you substitute the information with the information from the formula with the information from the problem. That's our given. Step 3, we simply solve. So let's look at this example up here. A runner arrives at the finish line 20 seconds after leaving the start, which is 100 meters away. How fast did they travel? I highlighted 20 seconds and 100 meters because that's information we might need. And I underlined the question. How fast did they travel? So they're talking about speed, how fast. So that tells us for number 1, the formula we need is speed equals distance divided by time. Number 2, you substitute or plug in the numbers. So we know the distance was 100 meters. So I wrote down 100 m divided by 20 seconds, or 20, the lowercase s. Step 3, we solve it. 100 divided by 20 is 5. And the m and s do not cancel, so speed equals 5 meters per second. Let's look at practice question number 1. Susan can run the 100-meter dash in 20 seconds. What is her average speed? Well,
Oh.